Hi, this class we'll understand the backpropagation of neural networks. So the program is on artificial neural network, and we are going to understand backpropagation in artificial neural network. So the first one, this is the code which is used for initialize. We'll look at the code which we'll be using from the all over the class. So this is the initialization of neural network, that is the network initialization, and this is activate function. This is used to calculate the sigma w of I into x of I, and the transfer activation, this is used to calculate the exponential value of, that is the sigmoid. This is a function which is used to calculate the forward propagation, and transfer derivative is the part of calculating the error values, and backward propagation is the main part of our program and our class discussion. Update weights is about how we update the weights, which is the last part of the backpropagation. The updation is made here, and the train network is used to this the function which is used to call the forward propagation function. This is used to call the forward propagation function, calculate the error that is being expected with the expected value, and calculate the that is the backward propagate error, and then update the weights, and finally to check whether the error is reduced to the expected value or not. So this is where we start with the program, and we give the data set. These are the inputs we are going to get, and epoch, that is the number of times that is used to be run executed, that is were calculated, and these are the inputs that is been taken. Then we'll call the initialize function. So this is a function which we'll be calling. So let us look at the forward propagation. This part is proper forward propagation. The input x1 x2 is given, and this input is given to the weights with calculated. Sigmoid is calculated here sigmoid is calculated, and these two becomes the input, and the sigmoid is calculated here. Sigmoid is 1 over 1 plus e power of minus net, and the net is sigma I over, that is wi into x of I. The sum of these values are the net. So this is the sigma value, and the net is given as w0 plus w1 x1, w2 x2, w3 x3, like this to wn xn. The net length is a linear unit, and the sigmoid is 1 over 1 plus e power of minus net. Now the backpropagation algorithm is as shown, and this backpropagation algorithm has 3 levels, and the first level is that the error that is calculated at the output network, and the error that is calculated at the hidden network, and the error calculated for the change of updation of the weights. So these are the 2 errors that is been calculated, and the weights are updated here. So this is for the hidden value, this is the error for the hidden value, this is the error for the output network. And now we'll call the function, that is initialize network function is called, and n inputs is passed. N inputs will be 2, and this will be 2, and the outputs, and the output will be 1. So that we are going to call. Now initialize the network function. So that is n inputs, hidden value, and outputs is taken. Initially we calculate the weights for each layers, that is weights that is to be calculated. That is there are 2 layers, that is the hidden layer and the output layer. So hidden layer weights are calculated with this, that is they are the random weights that is to be calculated. So the random weights are calculated. So this is the function that is used to calculate the random weights, and that is the inputs is 2, and 2 plus 1 3. There are 3 weights that is being calculated for each node, that is the neuron. So then this is the hidden value, and for the output layer also it is the same, that is the hidden plus 1, the input hidden plus 1, there are the weights that is being calculated. So number of weights is 1 time it is calculated. We'll look into this, and these weights are saved into the network. They are present the network hidden layer into the network keeps the hidden layer weights, and the network keeps the output layer weights. Okay, and this is returned, and the function is written, and the train network is called with the data set, and this is the data set, and so this data set is the inputs. Okay, so now we'll call the train network data sets, and in the train epoch, it depends on the epoch value. If epoch is 20, and it depends on that if it loops according to the number of times that you have given the value. If it is 20, it will loop till 20 times, that is here. So it depends on what is the epoch you give, and the weights is the network, that network keeps all the weights, and data set are the inputs that is being given, that is their x1 x2 inputs, and learning rate is 0.5, and the train data function is called, and the each row is selected for each row in the training data. So here for each row means we will select the first row, that is 2.78 or 2.550, like this. This is the input data that is taken, and this input, that is the first row, is taken and it is given. This is the first row and the network, and the forward propagate function is called. So this forward propagate function is called. Here the forward propagate function is being called, and here in this their network has a different layers, and each layers has neurons, and from whenever it reaches the layer that is the inner for loop, and it will call the activate function, and activate function accepts the input, which is the rows, that is the input that is being given, and the weights are calculated. This function, activate function, is called, and it calculates the sigma value of these inputs, weights and inputs, the sigma value, and with this sigma value, activate function adds up W0 value that is present in the row, that is calculated in the random weights calculation, and the activate function is passed to the transfer activation function, and this calculates the sigmoid function, and this sigmoid function is the new or neuron output. So for each neuron output, there is a sigmoid that is being calculated, so that is calculated at this point. So this is this values are the activation function. So that is W0 is the activation, W0, that is weights of -1, W0, that is weights of -1 is W0, and these weights into the inputs are these values. Okay, and this return type is called to the transfer function, and that calculates the sigmoid value. So here is the sigmoid value, 1 over 1 plus e power of minus net. Now here is the input, that is the weights that is being calculated here. These are the weights that is randomly calculated, and the inputs is x1 and x2 are the rows that is being given, and the weights are w1, w2, let's consider here, and w0, this is the last one, is the w0, and it calculates the each having the two neurons. These are the two neurons, so each having the two neurons, and the final output is this is the layer which calculates this the final output layer, and it has one weights, that is the one neuron weights, so W5 and W6, and these are the W5 and W6, and this is a new resultant sigmoid that we are getting. Okay, so x1 x2 are the rows input, these two inputs, and the weights, and it's calculated, and these are the weights, and the input is calculated with sigmoid for the next value. Now the activation function, here we can see this. So this is the weights, the forward neuron has three weights that you can call it as. For this neuron, this can be W1, this can be W2, and this can be W0. So W0, W1, W2, W0. And the row, the input data that is being given are x1, x2. So these two are the inputs, we can call it as inputs. So this is one forward. For each row, there is one complete forward propagation for each row. And also for each row, there is complete backward propagation. So there is, for each the input data, that each row input data that is been given, there is a complete forward propagation and there is a complete backward propagation. So that is this 2.78, this is 2.78 plus w naught, this is w naught into x1 into w1. So this is x1, this is w1, that is this value, and x2, that is this value, into the w2, that is this value. So you have a sigma of wi xi, this is the net, and sigmoid is this 1 over 1 plus e power of minus net. Now let us look at the same thing with a given example. So this is x1, so the input rows. So we can see that two input rows from the data set. This is one input row and the second input row is here. This is one. This is 2.78, 2.55, and this is the second input is 1.46 and 2.36. This input row has a complete forward propagation as well as backward propagation. Then it will come to the next row. Now let's look at, so x1 has, this is x1 and this is x2, and the forward neurons, the first layer has 2 neurons. So this is the layer and each layer has these weights. So these weights are, we can see here, w1, w0, w1, w2, w0, w3, w4, w0, and these are the 2 neuron weights, and you can see here weights, and these are the weights, that is w3, w4, w0, and you can see here. So that is what w1, w2, w3, w4, w1, w2, w3, w4, x1, x2, and w0 and w0. So this is x1, x2, w1, w2, w0, w3, w4, w0, and this is w5, w6, and w0. So this is w5, w6, and w0. So these are the values. Now let's look at it. This is the input x1, x2 is given to this first neuron. This is the first neuron inputs, and this is the second neuron inputs, and the sigma is calculated and the new output is created for each neuron. There are 2 neurons, 2 new values, sigmoid. This is the sigmoid value, this is sigmoid value that is calculated, and this is the next layer input, next level, and this is the sigmoid that is calculated by taking this input, these 2 inputs. And now the same thing is repeated. This output, this becomes a new input for the next cycle. So this is the input that has been given, data input, and row is, this is the new data input. For this new data input, this the sigmoid output will become the new input. So this input is given here. So this is 96. You can see here 91, 96, 96. Where is 96? 96 here. So this is the new input, and this is the new input. We can see here 9648, 96. This is the new row, and this is 964389. This is 964389. This is the new input, and this is the new input 991. So 9185. So that is the new input. So we can see here for this new row. So each row has the forward propagation as well as backward propagation. Now we discussed about the forward propagation. Now we'll look into the backward propagation. So when this complete cycle is completed, so it will come back to the train function. The train function gets the output, that is the new inputs are created, and the new inputs that are calculated, we can see here new inputs that has been calculated is passed over, and that becomes the new output. So that is the forward propagation, and the expected value and the error is calculated. The expected value and the error, the output obtained, expected minus the output obtained is the sum error. So total error, how much you are supposed to get, and this the expected value we are taking. So then to get the expected value, we need to reduce the error. So to reduce the error, the weights has to be updated. By updating the weights, that we can reduce the error. So to do that, we need to do back propagation. So that is the expected value, and now we start with the back propagation. Why? We need to update the weights. In order to, when we update the weights, we will get the back propagation value. So this is the algorithm for the backpropagation. This is the code for the backpropagation. We'll look into code. In this code there are two types. One is for this part is for the hidden value. This is the error that is calculated for the hidden value, and this is the error calculated for the network output layer -1 error. So there are two layers. That is there are three levels in backpropagation algorithm. This is the first layer. This is calculated. This is delta calculated for the hidden value for the network output layer, and this is for the network hidden layer. This is for the output layer, and this is for the hidden layer. And the weight updation is made here. That is eta into delta into x of I. Eta into delta into x of I is the weight updation, and delta is calculated for, this is the formula that is calculated for the hidden unit, and this is the formula that is calculated for the output unit. So there are two types. So we can see this. These are the two types. This is for the this is for the hidden layer, and this is for the output layer. So now that is what this is for the hidden layer. We know this. This is the formula. The sigma W of KH. Okay, we'll come here. So this is transfer derivative delta, and OK is the output. We have got 1 minus OK is the output. So that is the delta transfer derivative. So this part is the transfer derivative. So what which is written in the box is the transfer derivative. So this is the transfer derivative which is common for both. So transfer derivative common for both. So it is ultimately whenever, if these two condition, after these two condition is done, then it is multiplied with the errors obtained. So there are two possible errors that we can get. That is for this is for the output network output layer. So TK, that is TK is the expected minus obtained value. Expected minus obtained. TK is the expected and OK is the obtained. And this is the errors that is got by sigma W of into delta K. So we calculate this part. So there are two in the backpropagate error. There are two steps. That is, the first one is if condition, and if this if condition is for hidden layer, and this else condition is for the network output layer. Now we calculate this. Here each forward neuron has the output, weights, and the delta value. Now the network training function is we call this back after the back propagation is done. So the first one is the forward propagation is calculated. After forward propagation, the expected value is calculated. After calculation, the error is calculated, and to get the expected value, we need to update the weights. To do that, backward propagation is made. So then update weights are made. So weights are updated. So the weights updation is made. So that is eta into delta into x of I. So that is this formula, eta into delta into x of I. So this is L rate. This is eta is the L rate, that is the rate at which that is the learning rate, into neuron delta, that is we have calculated, into the input value. So now finally the network training example training is done. Now it will print the output. Thank you.